Hello class, good day. So today we will be discussing the fluid flow in pipes, the subtopics pipes discharging from a reservoir, pipes connecting reservoirs, and then series and parallel pipes. So more on the connection of pipelines ito. So let's start. Let's first discuss the pipe discharging from a reservoir. So at this figure, we have a reservoir and this reservoir is connected to this pipeline. At certain points ng pipeline natin, we have point A and point B kung saan meron tayong naka-attach na piezometer to calculate the head, no, pressure head at points na yan. No? So, piezometers natin yan. Okay. So, this reservoir and pipeline has its certain elevation. So, if you have here the datum, so, halimbawa, ito yung datum natin, naka-refer yan dito. So, we have our Z here, Z1, then at point A, we have Z2 or ZA. Yan. And then, ito naman, na from your datum, it is measured ZB. Ayan. So, these are your elevation heads, no? Referred to a certain datum. And so, again, these piezometers are used to calculate the pressure head at the pipelines, no? At point A and at point B. So, we have PA over gamma here and PB over gamma. Now, using the HGL, we can plot, no? Yan, yes, no, we can plot the HGL na from this figure. So, from the surface of your reservoir, nagkaroon tayo ng certain drop of the HGL due to the head loss, no, or pressure, head loss, tama, at this point, no, kung saan magkakaroon ng entrance, no, pagpasok yung liquid natin sa pipeline. So, yan yung nag-cause ng pagbaba ng ating HGL. So, bumaba yung pressure head natin dito. So, HGL, it is your pressure gradient, no? So, pinaplot niya kung saan yung point mo ng pressure head. So, at this point, the pressure head locates here. Ayan. So, dito, di ba, at the surface ng reservoir natin, we don't have pressure there. So, zero. Andun siya mismo sa, ano natin. 0, tapos nagkaroon ng pagbaba sa HGL, and then we have our PA over gamma, then PB over gamma, and up to doon sa point natin ng opening sa pipeline. So, we don't have pressure gauge there, no pressure head gauge. Okay? And then, when we will consider the velocity head, so, mapaplat naman natin si EGL, si energy grade line. It is your total head grade, no, grade line, gradient. So, paplat natin at this point from your surface ng reservoir nagkaroon ng pag-drop. So, that drop is due to the head loss again, no? Head loss doon sa entrance natin. Now, this head loss entrance, yan, so na-plot natin dito, no? This head loss entrance is a sample of a minor head loss. When we say minor head loss, ito yung mga head loss na kina-cancel natin kasi sobrang liit lang ng nako-contribute nila na head loss. So, we consider it almost approaching to 0 na. So, ayan, sometimes canceled out na yan sa equation natin. Then, so the distance between your EGL and HGL, so we had that topic, no, during the Bernoulli's energy equation. So that distance is your kinetic head, the V squared over 2G. Yeah, so take note, we don't have the velocity, no, at the reservoir kasi sobrang laki ng storage na yan. So, hindi na natin mapapansin yung pag-withdraw ng liquid there. But sa pipelines, pansin na pansin natin yung bilis ng pag-flow ng liquid natin dito. Kasi mas maliit yung cross-sectional area niya dyan. Okay? So, the certain drop on your EGL from this entrance is the head loss due to the friction in your pipeline. No? The friction between the pipe, the walls of your pipe, and the fluid that flows. So we call it HF. So we have the equations for HF no last meeting. We have the Darcy-Weisbach, Mannings, and the Hazen-Williams na equation for your major head losses sa mga pipelines. So ito yung nagko-contribute dyan. Okay? Now, the certain question here is to determine the head loss, the total head loss on your pipeline. Well, on this sample, when you have pipe discharging from a reservoir, you will be needing the Bernoulli's energy equation. You just have to take note of that. No? Pwede mo maging point na analysis is this. Point 1, yung surface mismo na yung reservoir. And then, yung point 2 mo naman is yung nagdi-discharge na yung when your pipeline is discharging to air. And then, so if pantay yung pipeline natin dito, so ZA and ZB will be equal, no? So the change in elevation natin, yun na lang yung pwedeng maging i-consider natin dyan. Ayan, kasi hindi pantay no, yung point 1 and point natin. So if it has Z2, no? Z2. So, magko-contribute yan sa Bernoulli's energy equation natin. And then the pressure head, yung pressure head natin, again, at point 1, wala ang pressure head yan. At point 2, wala din pressure head. Then, for the velocity head, at point 1, wala. But at point 2, meron. No? Meron tayong velocity there. Okay, bago siya lumabas sa when it discharged doon sa pipelines natin. Then, wag niyong kakalimutan yung head loss doon sa pipeline kung saan tinamaan. Now, meron dito sinasabi na if the pipe is horizontal and with uniform size, the difference in pressure head measures the head loss between the 2 points. So, it has something to do with your point A and point B. Yeah. Well, for this, again, no, for the analysis of your pipe discharging from a reservoir, the Bernoulli's energy equation lang yung kailangan ninyo. And also pala yung equation natin for the major head losses. Okay. So, babalikan natin the Bernoulli's energy equation. That is your E1. No. Now, we're considering head loss. No. Okay. HL equal to E2. Ayan. So, you just have to calculate the head loss from this Bernoulli's energy equation and also from the equations ng mga major head losses. Yeah. So, what if we have a pipeline that connects to reservoir naman? So, we have here a reservoir 1 and reservoir 2. So, we also plotted the HGL, the change in the pressure gradient, and also the EGL, your energy grade line. So, at this point, kung saan meron tayong entrance from the entrance of liquid from your reservoir 1, we have a certain drop on our EGL, and that is your HL entrance. Ayan. So, again, HL entrance is your minor head loss lang. Then, your liquid will travel from this point up to the point kung saan papunta na siya sa reservoir 2 natin. So, yung pag-travel ng liquid natin from this point, let's say point A and point B, no, has a certain drop on our EGL. So, nagkaroon ng pagbaba sa EGL and that is your head loss due to the friction sa wall ng pipelines and sa fluid. Okay? And then at point B, again, there's a certain drop on the EGL here. So that certain drop is your head loss man, sa exit. So HL entrance and HL exit is again a minor head loss. So we can cancel it no in our equation if not considered. So here we have to take note that when one or more pipes connect to reservoirs, the total head loss in pipes is equal to the difference in elevation of the liquid surfaces of the reservoir. Well, again, when you're considering two reservoirs, you can also use the Bernoulli's energy equation. So, ito lang yung panlaban natin dito. So, using this Bernoulli's energy equation, madederive mo yung binabanggit dito na when you're considering two reservoir connected by a pipe, the total head loss is just equal to the elevation. No? So, pakita natin. Ayan. So, we will consider point 1 and point 2. So, we have E1 minus HL equal to E2. Okay? So, E1, this is the total head at your point 1. So, we're considering reservoir. So, again, pag reservoir, we don't have, at this point, no, we don't have pressure head dyan kasi exposed sa air, no, yung liquid natin. And then, we don't also consider the velocity head kasi sobrang um, liit lang ng portion ng velocity there na hindi natin mapapansin yung pagbaba or pagtaas ng liquid natin sa reservoir. So, we're not considering the pressure head and velocity head there. So, ano lang yung kino-consider natin? Ang kino-consider natin is the elevation of this surface. So, tinatawag natin yan Z1, di ba? So, halimbawa, ito yung datum natin, yung pinakababa. Oops. Hindi, huwag na lang yan kasi masusulatan. Ayan. So, ito sa halimbawa yung certain datum natin, no? So, from the datum that is Z1, yung surface ng reservoir 2 natin, reservoir 1, and then yung reservoir 2 naman natin has its elevation head na Z2. So, wala tong pressure head and walang velocity head kasi nga reservoir. So, ano matitira sa equation natin? We have Z1 minus HL equal to Z2. Ayan. To solve for the head loss mo nga is just equal to the difference in elevation ng dalawa mong reservoir. Yan. So you can also relate this head loss no uh, to the head loss na nasa pipeline natin. Kasi this head loss entrance and exit are minor head losses. So we can relate that the total head loss is just equal to your HF. Yeah, we have two relationship ng mga head loss. The change in the elevation and the head loss due to the friction or major head losses. So what if we have a reservoir connected or a pipeline connected to 3 reservoir? So, paano naman natin siya ina-analyze? So, kanina, isang reservoir lang, tapos naging dalawa. Ngayon, we're considering 3 reservoirs connected by a certain pipeline. Now, we have 2 cases for this pipe connecting 3 reservoir. So, unahin natin tong case 1. Ano kayang meron sa kanya? So, this will be your reservoir 1, 2, and 3. They are connected by a pipeline. No? So, pipeline from 1, then 2, and 3. Tapos, magkoconnect sila at this point. So, that point is your point J. J means junction. Yeah. So at that certain point, your pipeline's connected there, no? And that is your junction. So, the datum here is really important kasi yan yung magbibigay sa atin ng head loss natin, 'di ba? So, sabi natin kanina, if we're considering dams or reservoirs, the change in the elevation, yan yung magiging head loss mo. So, the datum dapat known natin. And so from the datum, we can measure the elevation head of your reservoir 1, 2, and 3. So this H1 is your elevation at elevation head at reservoir 1, H2 for reservoir 2, and then H3 for your reservoir 3. Then this junction, it also has its elevation, no, from the datum. No, elevation head from the datum. So tawagin natin siyang HJ. Yan. So important kasi dito na malaman natin yung location or position ng pressure head at the junction. No? Dahil diyan tayo magbe-base ng kung ano yung amount ng head loss, no, from your connection ng reservoir to junction, no, na mga connections. So, yan yung major natin dito na goal. Ayan. So, let's say, no, at the junction, we have this point, J prime. Yan yung certain na pag-angat due to the pressure head at the junction. So, that is PJ over your gamma. Now, if you know that J prime, madali mo nang makukuha yung head loss from your reservoir to the junction. So, that is just, no, measured, no, from the liquid surface to J prime. So, that is your H1, HF1. Then, in this case 1 pala, no, we assume that J prime is higher than your reservoir 2. So, what does it mean? No, meron tong kinalaman sa magiging flow rate natin. So, mas mataas si J prime, no, ibig sabihin, your reservoir 1 will supply liquid to your reservoir 2 and reservoir 3. Kasi mas mataas to eh. Yan. So, junction dyan connected yung iyong mga pipelines. So, reservoirs, they are located on the highlands, no? Para makapag-store sila ng liquid. And then, ayan. No? So, at this point, diyan natin malalaman kung ano ba yung magiging direction ng fluid natin, kung saan siya pupunta. Now, kapag nalaman mo na mas mataas si J prime sa isa mong reservoir or two reservoirs, so meaning your first reservoir is used to store or to supply, no, liquids to this other reservoirs. Ayan. Then, pwede mo din i-calculate yung head loss at point 2. So, that is measured na from J prime to the liquid surface here. So, we have HF2. And then also, ayun, pwede mo rin makuha yung head loss natin at the third reservoir. So, measured again from J prime up to the liquid surface natin at the third reservoir. So, more on identifying the distances lang kapag you're analyzing reservoirs. So, ang main goal, no, first na goal mo is to determine the location of your J prime. Pag nakuha mo na si J prime, sobrang dali na ng execution ng problem. Okay. So again, in this case 1, we have J prime higher than your second reservoir and third reservoir. Meaning, your flow comes from your first reservoir. So, nagsusupply siya doon sa dalawa. So, yun mga drawings natin dito sa 3 reservoirs, sometimes like that, no? Iko-confuse ka niya if your junction is higher than your reservoir 2 and reservoir 1 or lower than. So, you always have to check yung J prime, hindi yung point J na to. So, J prime, that is your pressure head, no? Pressure head sa junction. So, at junction, that is the connection of your pipes no, from the 3 reservoir. Yeah. So, at J, no, we have Q1. Makakuha tayo dito ng relationship na since si Q1 or si reservoir 1 yung nagbibigay sa atin ng liquid. So, Q1 is just equal to your Q2 and Q3. No, Q2 plus Q3. So, this is from the continuity equation lang din. No, what comes out is what comes in. So, ang nag-supply si Q1 or yan, tama, no, Q1 yung nagbigay. So, paghahatian nung dalawang reservoir natin yung flow na 'to from your reservoir. That is your case 1. Now, yung case 2 naman is yung mababa si point, J prime dito sa second reservoir natin. Tapos mataas siya kay third reservoir. So, that is our case 2. And so, if you know, again, kapag alam mo na yung location ni J prime, madali mo makukuha yung mga head losses natin. Kasi, from the liquid surface to your J prime, that is just your head loss. Ayan. So, katulad dito, from your reservoir 1 up to the J prime, you have HF1. Then, J prime, or tama, J prime up to the liquid surface, that is your HF2. Then, J prime up to the liquid surface sa third reservoir, HF3 naman. So, mababa si J prime at dito, sa reservoir 2 natin. Ibig sabihin, we have 2 reservoir supplying the third reservoir. So, we have Q1 and then Q2 pababa, no? Yung parang magiging flow niya. So, magsusupply si um, reservoir 1 and reservoir 2 kay reservoir 3. Now, we have this relationship na Q1 plus Q2 is equal to Q3. So, again, this is from your continuity equation. What comes in, what comes out. Next, we have pipes connected in series and parallel. O, kailangan alam natin yung mga certain equations na regarding this connection. Ayan. So, let's discuss first the series connection. So, we have here a certain pipeline that changes its diameter and length. No? So, there will be a flow rate, from this point. So may Q1 tayo dyan. Then, at this second pipe, we have Q2 and then Q3. No? So, we know that this is in series na connection. So, from your continuity equation, what comes in is what comes out. So, kung Q1 to, yung Q2 natin equal lang kay Q1, and then si Q3 is equal to Q1. Series kasi yan na connection. Then, when it talks about the head loss, so the head loss is just equal to the friction loss, from your point 1, point 2, and point 3. So, actually, it comes from your Bernoulli's energy equation lang din. So, kung ano yung nadaanan mo na pipeline, so may consider ka dyan na head loss, so i-consider mo. So, you have to add it up. Ayan. So, pwedeng mag-contribute din dito is the changes in elevation, the pressure head, and the velocity head. Okay? So, hindi pa rin natin dito makakalimutan si Bernoulli's energy equation when we're analyzing series pipes. Now, kapag naman nag-a-analyze tayo ng parallel pipelines, so parallel pipelines, ito naman siya. Nagkakaroon tayo ng branching. Ayan. So, we have point A and point B here. And so, from this pipeline number 4, nag-branch out siya into 3. So, we have 1, 2, and 1, 2, and 3 here. Tapos, magmi-meet sila at B. So, point A and point B are your junctions ng pipe mo. So, diyan nyo makikita yung connection ng pipeline. And then, at point B, isa na sila, there's the junction, tapos lalabas na siya dun sa pipeline natin, yung liquid. Now, ano naman yung magiging equation natin dito. So, when it comes to the Q, ayan. So, halimbawa may pumapasok tayo na flow rate from your point 4, yung point 4 natin, magba-branch out siya, 'di ba, sa tatlo. So, meaning this Q4 will be divided into 3. No, not necessarily equal to 1/3 nito. So, depende pa 'yan, no? Depende 'yan sa magiging cross-section ng pipelines natin. So, hindi siya 1/3 talaga. So, it will be divided into 3. So, we have Q1, Q2, and Q3. And then, after that, no, pupunta na sila sa point B. So, we have their Q5. Now, Q4 and Q5 from this analysis is equal. And Q4 and Q5 is equal to your Q1 plus Q3 plus Q2. Yan, kasi, again, continuity equation. Now, when it comes to the head loss, we have this relationship na kung ano yung head loss at point 1, it is also the head loss at point 2 and head loss at the point 3. Yan. So, it has something to do with the velocity, heads, the pressure head, and elevation head, and also the fluid friction on the pipelines. And so, maintindihan natin tong mga concepts na to about the pipeline connection when we apply it on the problem. So, let's try this problem number 1. So, a 20 mm diameter commercial steel pipe, 30 meter long, is used to drain an oil tank. So, determine the discharge when the oil leave oil level in the tank is 3 meter above the exit of the pipe. So, neglect minor head losses and assume F is equal to 0.12. So, sulat natin yung given. The pipeline has these properties: diameter 20 mm, as length, na overall length na 30 meter. Okay. So, it is given na the discharge, the oil level in the tank is 3 meter na above the exit of the pipe. Yan, yung head ng oil natin dito. So, this is on oil. Okay? So, we will be neglecting the minor losses, yung minor losses due to the entrance of the liquid here at the point kung saan mag-i-start pa lang yung pipe natin. And then, we have a friction factor na 0.12. And so, sabi natin kanina, when we're dealing with a reservoir connected to a pipeline and then discharging, we can use the Bernoulli's energy equation. So, dito, to determine the amount of flow rate at this point na nade-discharge sa pipeline natin, we will be using the Bernoulli's energy equation. So, tawagin natin si BEE. From BEE, we have this equation na E1 minus HL. So, we're considering head loss dito, no? It's equal to E2. Yeah, so, E1 is equal to your pressure head. So, take note your unit weight there is for oil. And then we have B1 squared over 2G plus Z1. Then minus HL equal to P2 square, P2 lang over gamma of oil. Okay, kasi oil yung nagpo-flow sa atin dito. B2 squared over 2G. Then, plus Z2. Ayan. So, analyze natin. Let's have our point 1. Point 1 natin is this one, para mas madali. And then, ito naman yung point 2 natin. Ayan. So, on this sample, ang gagawin natin datum is your point 2. So, ito yung datum. Diba? Ayan. So, analyze natin sa point 1. At point 1, we don't have the pressure head there because exposed sa air. So, cancel. Velocity at the reservoirs are almost approaching to 0. So, we don't have velocity head. For Z1, that is your change in elevation at a certain datum. So, point 1 is 3 meter high, no, from your datum. So, we have positive 3. Okay, so may value tayo dyan. And then, minus HL. Now, HL here is the certain drop, no, from your EGL that is from the head loss sa pipeline natin, from the major head loss. Okay? So, the minor head loss, hindi natin siya i-consider kasi sabi sa problem, neglect. So, HL here is equal to your HF. No? And we have certain equation for HF, the major head losses. We have Darcy-Weisbach, Hazen-Williams, and Mannings. But here we have a given factor, the picture factor. So, gagamitin natin is si Darcy-Weisbach. So, recall the equation for your Darcy-Weisbach. It is 0.0826 FL Q squared over D raised to 5. Ayan. So, we will just substitute the given diameter, length, and friction factor there. Then, Q is the flow rate here at the pipeline. And that is also the Q at your point 2, yun na discharge. So, dito, magkakaroon tayo ng variable, no, for the Q. So, lagay natin sa equation. So, we have 0.0826 F 0.12 L is given 30 meters. Q squared, diameter must be in meters. So, we have 0.02 raised to 5. Okay? That is your head loss. And equal to 0.2. So, 0.2 natin, exposed sa air. So, we don't have pressure head. We have velocity there. No, calculate natin velocity. But, hindi naman velocity yung hinahanap natin. No, Q. Makukuha natin um, yung equation ng velocity by this equation of Q is equal to AV. Now, you just have to divide yung Q natin with the area, cross-sectional area of the pipe, no, to calculate for the velocity. So, yan yung gamitin natin. Rewrite natin yung equation. So, we have V is equal to Q over A. So, what is your A? Now, yung A mo is the cross-sectional area of your pipe. Now, we have pi over 4. D is 0.02 squared. Yeah, so we'll be substituting it in this equation. So we have Q over pi over 4, 0.02 squared. Yeah, so don't forget, naka-square yung V natin dyan. And then, divide natin sa 2G. G is the gravitational acceleration. Then, ano naman si Z2? Si Z2 is yung datum natin. So, ito ay 0. Ayan. Here, we have the only unknown na Q. Masasolve natin siya agad. Ayan. So, you can simplify this equation or pwede naman gamitin si Shipsol. So, if gumamit ng Shipsol, makukuha natin si Q. Q is sobrang liit na value, 1.792 times 10 raised to negative 4 cubic meter per second. Ayan. So, wala namang binigay na unit. Pwede pa natin to isolve into liters per second. You just have to multiply it to 1,000. So, you have 0.179 liter per second. So, this would be our answer for this sample problem number 1. So, kahit alin dyan. Kasi, same naman yan. Wala din binigay na unit na hinahanap. So, Bernoulli's energy equation pa rin, no? Yung ginagamit natin for the analysis ng mga pipeline connection natin. Nadagdagan lang na equation for the head loss sa pipelines. Yung major head losses. Okay, so, let's proceed. We have sample problem number 2. For sample problem number 2, we have A 2.5-meter diameter pipe of length 2,500 meter conveys water between two reservoirs at a rate of 8.5 cubic meter per second. So, what must be the difference in water surface elevations between two reservoirs? So, neglect the minor head losses and assume F is equal to 0.018. So, sulit natin yung given the properties of your pipes. The pipeline has its diameter na 2.5 meter. It has its length. So, it conveys water from this reservoir to another 2,500 meter yung kanyang length. Okay. And then, the flow is 8.5 cubic meter per second. Yeah. So, what must be the difference in elevation between the two reservoirs? If we have F na 0.018. Yeah. So, if you have their samples, you can always apply the Bernoulli's energy equation. So, tawagin natin si BEE, no? So, doon meron tayo equation for the difference in water surface elevations. So, BEE, it is your E1 minus the HL equal to E2. Yeah. So, E1 or what would be your point 1 and point 2? So, ang gawin natin, ito yung point 1 and ito naman si point 2. So, point 1, the total head loss is P1 over gamma. So, water naman yan. Then, plus B1 squared over 2G plus Z1. No? Minus HL. So, HL here is due to the friction and the pipeline. So, that is the major head loss. Ang gagamitin natin, since given yung friction factor, is the Darcy wasteback. So, 0.0826, no? FL Q squared over D raised to 5. Ayan. So, substitute ko na dito, no? We have 0.0826 FL Q squared over D raised to 5. Ayan. Then, equal to E2. E2 natin is P2 over gamma plus B2 squared over 2G plus Z2. Ayan. So, let's have our datum. No? So, halimbawa, itong datum natin. So, we have our elevation head at point 1. That is Z1. And elevation head naman natin dito. So, measured from the water surface, no? Z2. This is your datum. Okay? So, analyze natin si point 1. Si point 1, it doesn't have pressure head kasi ang gauge pressure natin is 0. So, exposed sa air. So, ito cancel. Then, also consider the velocity on the reservoirs. Almost approaching to 0. No? And then, we have Z1. May value tayo ng Z1. Okay? Then, minus the 0.0826. Lagyan natin ng value. 26 F natin 0.018 L given yan 2,500 Q given din 8.5 8.5 ito no hindi siya 85 so paghiwalayin natin ayan squared so again no for the equation ng mga major head loss natin sa mga pipelines dapat that is for SI units lang, no? Hindi sila pwede sa English unit. So, make sure you have to check your units. Dapat naka-meter and then second, naka-meter. So, cubic meter per second squared, D, 2.5 meter raised to 5. And then equal to P2 over gamma. At point 2, we don't have the pressure head and also don't have the velocity head there. Yan, kasi reservoir ina-analyze natin. Then, we have Z2. Okay? So, Z2. Ayan. So, ang tinatanong is the difference in water surface elevation. So, we have Z1 minus Z2. Yan pala ay ito lang. No, si 0.0826, 1825, 8.5 squared over D raised to 5, 2.5 raised to 5. Ayan. So, ito yung sinasabi natin kanina na when you're analyzing um, reservoirs, it has something to do with the elevations head lang, no? Difference in the elevation head. Ayan. So, simplifying, the difference is 2.75 meters. This is our answer for sample problem number 2. Okay, so let's have another sample. So, two reservoirs are connected by two pipes. The difference in elevation of the two reservoir is 46 meters. So, connected sila ng dalawang pipes. Ayan. Okay. So, ito yung pipe 1 and then pipe 2. Or, ayan, papakita natin dito sa figure. So, the first pipe is 0.3 meters. Ayan, so, ito yung ginawang pipe 1. 0.3 meters in diameter, 8,050 long, no meter long, the length of your pipe, and then it has a friction factor of 0.02. Then the other pipe is 0.35 meter in diameter, 8,021 meter long, the length, and the friction factor is 0.02. We are required to determine the total flow connected by the two pipes. Ayan. So, pag sinabing two pipes, ganyan siya, no, connected siya na ganito. So, hindi naman pwede na we have pipe 1 here, tapos may isa ka pang pipe 2, or isa ka pang pipe na magko-connect sa kanya dito, na para maging two pipes. Ayan, so when you're analyzing no two pipes, connected lang sila dito in series. Ayan. So, let's say this is our point A and point B, or pipe A and pipe B na lang pala. So, analyze natin yung problem. So, let natin yung mga given. So, the change in elevation of your reservoir is 46 meter. So, ito, na-figure out lang siya from your sample problem, no? From the problem itself. Kasi sometimes sa mga ganitong um, situational na mga problem, hindi binibigay yung figure. So, how are we going to determine the total flow? So, again, if you're analyzing reservoirs, pwede mong gamitin lagi, no? Si Bernoulli's energy equation. So, BEE lang ang sagot sa lahat. So, BEE is E1 minus E2 or minus HL equal to E2. Ayan. But, na-derive na natin to kanina. Your head loss is just equal to the change in elevation, Z1 and Z2. And, consider the total head, on your pipeline. So, we have two pipes dito, na connected. So, kailangan mo i-consider yung magiging head loss sa pipe A and sa pipe B. Hindi pwedeng pipe B lang kasi tatama or dadaloy naman yung tubig natin dito sa pipe B to pipe A. Ayan, so hindi pwedeng pipe B lang, no? Kasi ibig sabihin doon, huminto ka na ng analysis mo at the pipe B, no? Yan yung yung kino-consider. Yeah, so if you want to consider halimbawa yung point kung saan may connection yung at point na Ayun, connected yung pipe A and pipe B mo. Puwede naman, pero magkakaroon ka ng mga certain unknowns, pero pa rin, 'no, pa rin naman siya. But for easier solution, maganda ang inire-relate mo is your reservoirs, 'no, yung water surface ng mga reservoir mo. Para hindi ka nabibigyan ng other variables, 'no, in your equation. Di mo na kailangang hanapin, 'no. Kasi ang dami naka-cancel, 'no, when you're considering reservoir. Walang pressure head, wala ding velocity head, 'no. So, elevations lang yung kailangan mong i-consider. Now, for this head loss, it is also equal to the summation ng major head loss at your pipe A and pipe B. So we have HFA plus HFB. No, equal din sila dyan. So the flow, yeah. So the flow is from your reservoir 1 to reservoir. So from the given, we have the change in the elevation of your reservoir. It is given, 46 meter. So, ito yung magiging mother equation natin for this problem. So, Z1 minus Z2, that is 46 meter. No? Equal siya sa HFA plus HFB. Ayan. So, given tayo dito ng equation ng friction factor. So, what major head loss equation yung gagamitin natin? So, kapag ganyan, Darcy, raise back agad. Now, we have HF equation, no? 0.0826 FL Q squared, no? D raised to 5. Ayan. So, let's calculate lagay natin, substitute natin dito yung mga values natin, no, for A and then for B. So, HFA muna tayo. We have 0.0826. F for pipe A is 0.02. We have L. Length niya is 8,050. Okay. QA. We have QA there. Then square. Now, divide natin sa diameter niya. 0.3 meters naman yan. 0.3 raised to 5. And then, plus the head loss at point B. So, it follows the equation of Darcy raised back again. We have 0.0826. F natin 0.02. Length ay 8021. Then, what is your Q? Yung Q mo dyan is QB. But, again, from your continuity equation, what comes in, what comes out. No? So, QA is just equal to QB. Ayan. So, para hindi ka na madagdagan ng ano dito, lagay mo na lang QA. Or Q na lang. Ayan. So, that is your Q. Total flow on the pipe. Yan din yung wini-withdraw ng reservoir 1 mo. Papunta kay reservoir 2. Okay? So, wala namang ibang lalabasan yan eh. Kasi pipeline lang naman yung connection natin dito. Okay? And then, divide this the diameter. So, diameter is 0.35 raised to 5. Okay, here, the only unknown is the Q, the total flow, no, from your reservoir 1 and 2. So, masasagot natin siya agad. So, Q here is 0.0758 cubic meter per second. So, that is our answer, no, for this sample problem number 3. And so, for the next problem, we will be analyzing reservoir naman, 3 reservoir. Sample problem number 4. So from the given figure, the rate of flow from reservoir A is 0.2 cubic meter per second. So compute the head loss at pipe B, yun yung unknown, no? And discharge at C and the diameter at your pipe C. So yun yung mga ano natin. Given yung elevation of your reservoir. So elevation, when you say elevation, kapag binigyan ka ng elevation from your surveying, that is measured from a certain datum. So, analyze natin tong 3 reservoir natin. So, to calculate for the head loss, discharge, and diameter. So, first thing na kailangan nating malaman is the location of your J prime, no? So, kapag nalaman mo na si J prime, maso-solve na natin yung hinahanap dito na head losses, discharge, and diameter. So, kailangan lang natin siyang i-consider. Now, from the given, it says that your reservoir A has the rate of flow na 0.2. So, reservoir A is higher than your reservoir B and reservoir C. So, it may be provide, no, supply to these 2 reservoirs. So, hindi pa natin sure, no? So, we have 0.2. Hindi pa natin sure kung siya lang, pwedeng si B din, no? Based on the position of your J prime. So, we will check it by determining the position of your J prime. So, makukuha natin si J prime by solving the head loss, no, at point A. Then, subtract mo yung elevation ni A, no, elevation ni reservoir A. Then you will determine the elevation of your J prime. So, calculate natin, no, head loss at A. So, the head loss at A, we are given here the C, no, the constant ni Hazen-Williams. Hazen-Williams constant, no, coefficient. So, ang gagamitin nating equation dito is C is yung kay Hazen-Williams. So, recall natin equation. Ito siya. Na 10.67 L Q raised to 1.5 over C raised to 1.5 D 4.87. Ayan. So, if malalaman natin yung head loss at point A, we just, again, subtract lang, no, yung head loss dito sa elevation ni point A, malalaman mo na yung position ni J prime. So, substitute yung mga given. So, we have length ng pipeline at point A, that is your 600 meters. So, ito yung length. Tapos yung maliit diameter. Okay. So, we have 600 meter length. Q is 0.2. It is given from the problem. So, raised to 1.85 over C. C is 120 raised to 1.85. D is 4.87. No? D, 0.45 raised to 4.87. So, simplifying HFA, it is equal to 2.268 meters. Yan yung head loss dito sa pipeline na to, papunta kay junction J. Ayan. So, to determine the J prime, no, it is equal to your, again, elevation head, or elevation at point A, minus your head loss. So, minus natin, we have 346 minus 2.268. So, 2.268 ito. Ayan. No, minus 2.268, that is equal to 343.732. Ayan. So, you now know the elevation of your J prime, no? Given ka ng elevation at A, tapos subtract mo lang. Yan na yung elevation at J prime. Now, we determine that J prime is higher than your reservoir 2 and reservoir C. B and C. So, yung A nga, yung nagsusupply sa dalawa nating reservoir. So, um, magagamit natin yon for the relationship ng mga discharge, no? Discharge at B, C, and A. But, for the first question, no, determine the head loss in pipe B. So, determine the head loss in pipe B. So, alam natin yan na ang head loss natin at the pipe B, at the pipe B is just the difference in elevation of your junction prime up to your water surface elevation sa reservoir natin. So, given na to, no, meron kang J prime, no, subtract mo dito sa 301. So, that is just your head loss sa pipe B. So, calculate natin, that is your 343.732. Ayan, so 732 to guys. Minus 301. So, subtracting, we have 42.732 meters. So, that is the head loss at your pipe B. Answer yan. Okay. Yeah. Next is to determine the discharge in pipe C. To determine the discharge at pipe C, we must know the value of the discharge at B. Kasi alam na natin, no, yung magiging flow niya, no, from point A, yung from A natin, siya yung magde-distribute sa C and B. So, maghahati sila sa point 2. So, let's determine the QB. No. So, determine natin by the given na head loss. So, we have the equation of major head loss by Hayes and William. It is 10.67, LQ 1.85, C 1.85, D 4.87. So, substitute the given. We have 42.732 meters equal to 10.67. Length I, 3,600. No? QB as unknown. So, raised to 1.85 over C. C is given 100. No? On this given figure. D is 0.3, then raised to 4.87. Now here, ang unknown lang is your Q at point B, no? So, solve natin agad si QB. QB is 0.106 cubic meter per second. Ayan. So, malalaman na natin ngayon agad si discharge, no, at the pipe C. Now, take note, no, the change in elevation of your J prime and the water surface elevation at your reservoir is the head loss. So, ito, si HFC. So, magagamit din natin yan to determine the diameter naman, no? So, ngayon natin hanapin si HFC, no, kunin muna natin si QC. So, si QC will be from your QA is equal to QB plus QC. Ayan. So, QA ay 0.2, QB 0.106, QC lang yung unknown dito. So solving for QC, QC ay 0.0936 cubic meter per seconds. Ayan. So, next is to determine the diameter of pipe C. So, makukuha natin yung diameter of pipe C if um, by, if we have the relationship of your head loss and the Q lengths and yeah, yung equation natin for the major head loss ni Hazen-Williams. So, solve muna natin si HFC. Ayan. So, si HFC, hindi natin masosolve yan using this equation. No? Kasi we have L, we have Q, no? We have C, but we don't have the diameter. Yeah, so we have two unknowns here. So anong gagamitin natin? Gagamitin natin is the relationship of your J prime and the elevation at the reservoir. So solve natin. The HFC is just equal to the change in elevation of your J prime, which is 343.732 minus your elevation at the water surface ng reservoir C, which is 241 meters. And so subtracting, we have HFC equal to 102.732 meters. Ayan. So we have now the head loss. So pag sinalpak natin dito yung mga given, masasolve natin agad si diameter. So lagay natin, we have 102.732 equal to 10.67 L12 Q, nasolve natin 0.0936 raised to 1.85 over C na 110, no? Raised to 1.85, D 4.87. Now, wag kayong mag-shift solve ng nasa baba yung inyong unknown. So, ilipat nyo muna to si diameter sa kabila, no? And then, shift solve. Or, mas maganda kung isi-simplify nyo na lang siya, no? I-divide mo to dito, si 102, then raise sa 1 over 4.87 itong whole equation, no? Masosolve mo na si diameter. So, kahit ano gawin nyo, diameter is equal to 0.184 meters. Yan. So, this is the application of your tree reservoir. So, ang nagawa natin dito is the case 1. No? Mas mataas si junction prime, no? J prime, the pressure head, no? Ng junction natin. Kesa doon sa dalawa nating reservoir. Reservoir B and C. So, let's have another sample now. The sample problem number 5. So, reservoir pa rin. So, 3 reservoirs are connected or interconnected as shown. Calculate the discharge in each pipe. Okay, so, given is the change in elevation of your reservoir 1 and 3, 90 meters. Reservoir 1 and 2, 20 meters. And the pipeline's properties. No? Pipe 1, pipe 2, and pipe 3. So, friction factor yung ginamit dito. So, we will be using the major headless equation of Darcy-Weisbach. So, analyze natin siya. So, on this problem, the elevations are not given. Okay? Hindi given yung elevation natin. Then, hinahanap is the discharge in each pipe. So, dito, hindi natin malalaman if your reservoir 1 ba is supplying reservoir 2 or 3 or si reservoir 1 and reservoir 2 nagbibigay kay reservoir 3. No? So, we don't know. No? Kasi hindi naman natin alam yung elevations nila. So, kung alam natin elevation, no, solve for the head loss, ayan, and then, compute for the position of your J prime, and then do the work, no, for the unknowns. No, but here, hindi natin alam yung magiging positioning, no, kasi hindi binigay. So, ang gagawin natin is we will assume, no, we will assume what will be the position of your junction. So, let's have the equation, no, for the head losses and the Q at your reservoir 1, 2, and 3, or sa pipeline 1, 2, and 3. So, sa pipe 1, we have this equation na 0.0826 FLQ squared D raised to 5. So, we will substitute yung properties ng pipe 1 natin. So, Fi 0.013, L is 2,000 meters, Q hindi natin alam. So, that is QA or Q1, no? And then, divide natin sa diameter na 1 meter. Ayan. So, we have Q1 is equal to 0.682 square root ng HF1. Ayan. So, sinimplify lang natin yung equation natin para mamaya, no, isa-substitute natin siya. So, equation ng Q with respect to the head loss. And then, compute din natin yung sa pipeline number 2. So, for the pipeline 2, we have 0.0826, Fi 0.02, L 2,300, Q2 squared, over D na 0.6 raised to 5. Now, simplifying and solve for the Q2, it is equal to 0.143 square root ng HF2. Yeah, so, equation 1 and 2 natin to. So, dagdagan natin equation, we have, for the pipeline number 3, so we have 0.0826, F is 0.023, L is 2,500, Q3 squared over diameter na 1.2 raised to 5. Ayan. So, simplifying, no, and solve for Q3. Q3 is 0.724 square root ng HF3. Ayan. So, again, in this problem, we don't know if kung saan papunta yung liquid natin. Ang alam lang natin, mas mataas si elevation 1 dito kay si reservoir 1 kay 2 and 3. Okay? So, hindi natin alam kung si reservoir 2 ba is nagpo-provide din ng supply kay 3 or hindi, no? So, we will be needing an assumption wherein we will check for the amount of head loss or amount of Q dito nila. Mag-a-assume tayo. So, the assumption is the J prime is located exactly at the surface elevation neto reservoir 2 mo. So, at that point, no, yung Q2 mo is equal to 0. Ayan. So, that is the assumption. You will assume that Q2 is equal to 0. So, 0 cubic meter per second. So, if that's the case, your J prime ay pantay lang dito. Ayan. So, that is your assumption. Okay? So that you have the head loss now. No, you can calculate the head loss at your reservoir 1. So, that is the change in elevation, HF1. And elevation, that is 20 millimeter. So, HF1 mo is equal to 20. Yan. So, if you will substitute this value of HF1 dito sa equation natin ng Q1, masasolve natin um, yung Q1. But that is not your Q1 talaga, no? For checking lang siya ng magiging flow natin, no? Based on this assumption na yung Q2 is equal to 0. So, let's solve for Q1. Ayan. So, dito, no, yung Q3 na, yung HF3 natin, masasolve din natin, no? That is the elevation ng J prime minus this. So, that is 70. Galing lang dito sa mga given natin, no? Kung 20 to, ayan. So, 90 minus 20, 70 meters. Ayan. So, let's solve for Q1. So, this is to check, guys, no, if what will be our flow. So, Q1 is equal to 0.682 square root ng 20 yung HF1 mo. So, Q1 is 3.056 cubic meter per seconds. Ayan. Then, Q2, alam mo yan, 0. No? Dahil yan yung ginawa mo assumption. No? You assume that Q2 is equal to 0 and also assume that the J prime is same on the elevation ng reservoir 2 natin. Then, compute then si Q3. Now, if you have your Q3, that is equal to 0.724 square root ng 70. So, Q3 is 6.055. Now, ano yung marirealize natin on the given, no? Q1, 3.056, Q2 mo 0, tapos Q3 is malaki. So, if your Q1 is greater than Q3, no, in this relationship, no, Q2 mo is towards your reservoir 2. And J prime is above 2, no, reservoir 2. Yan. But if your Q1 is less than Q3, no, Q2 is away from reservoir 2 and J is below, no? Reservoir 2. Ayan. So, this is the checking na part. Na if your Q1 is less than or greater than pala, no, greater than Q3, yung Q2 mo is going towards the reservoir 2, no? So, halimbawa, ayan, no, Q1 is greater than. So, si Q1 or si reservoir 1, siya yung nagsusupply. And then, um, nalaman mo, no, na from this checking, Q1 is greater than Q3. So, yung Q2 mo daw will go towards your reservoir B, and then your J prime is located above, no? J prime. Ay, J prime is above your reservoir 2, somewhere there. No? But if you had checked that your Q1 is less than your Q3, no, what happened? Yung Q2 mo will uh, be away, no, from the reservoir 2. So, away, papalayo. Yan. And your J prime is now located below the reservoir 2. So, dito located si J prime. Now, from the result of our assumption, you know, Q1 is less than Q3. Ayan. So, alin dito yung nag-govern? So, ito. Okay? So, your Q2 is away from the reservoir 2, meaning si Q1 and si reservoir 1 and reservoir 2 will supply your reservoir number 3. Yan. So, junction J is below the reservoir 2. Ayan. So, bababa siya, no? That is from the check. Yan yung gagawin natin gagamitin when you don't know the position of your um, reservoirs and your J prime. So you will assume. And then check for the amount of your Q1 and Q3. And so always remember this one. Okay? Now, yung mga nasolve natin value ng Q1, Q2, and Q3 here, hindi yan yung sagot na discharge sa pipeline natin. Okay? Yan lang yun sa assumption natin na si J prime ay pantay. But at the end, no, ang nalaman natin si J prime ay mas bababa. So, eto, mas madali na natin masosolve yung problem natin. We just have to relate, no, yung mga distances. Okay? So, we know that Q1 plus Q2 is equal to Q3 from this figure. No, we know that your reservoir and reservoir 1 and 2 supplies reservoir 3. So, nalaman din natin na si J prime is mababa sa ating reservoir 2. No? So, madali na natin itong ma-relate yung mga distances. So, the change in elevation of your reservoir to junction is the head loss. So, this is your HF1. Then, calculating naman dito or measuring, we have HF2 and then next is HF3 naman. Now, we have this relationship. Ayan, so total to, no? From reservoir 1 hanggang dito, HF1. Now, we have this distance na from the water surface elevation up to J prime, that is your HF2. Ayan. So, HF1 is equal to your 20 meter plus HF2. Ayan. So, magkakaroon tayo ng relationship dito ng HF1 and HF2. So, they are equal to HF1 minus 20. Now, from this distances. Ayan. So, equal sila, no, from your J prime. Para ma-lessen yung unknown natin pagdating dito sa equations. Doon, di ba? Ang dami natin equation. 1, 2, 3. Tatlo pa lang yung equation natin, but we have 6 unknowns, no? Actually. So, ito yung magagamit natin na mga relationship na from the figure ng reservoir. And so, nalaman natin na si HF2 is equal to HF1 minus 20. So, ano pa? So, si HF3. Now, si HF3, it is your measurement from your J prime up to the water surface elevation. So, we have total na change in elevation ni 1 and 3, that is 90 meters. Ayan. So, makakuha din tayo dito ng relationship na 90 meters no, minus HF1 is just equal to your HF3. No? No, relate lang. So that, HF1 na lang yung gagamitin natin for the following. Ayan. So, we will substitute, no, yung mga HF1 natin dito. Ayan, yung equation natin ng HF1, HF2, and HF3 sa Q1, Q2, and Q3 respectively. Then, apply it on this equation na nabuo natin from the assumption. So, we have Q1 plus Q2 is equal to Q3. So, Q1 is equal to 0.682 square root ng HF1. So, hindi pa natin alam ng value ng HF1, no? Then, plus Q2. Q2 is 0.143 square root ng HF2. Now, to lessen the unknown, let's write this HF2 in terms of HF1. So, we have HF1 minus 20. Okay? And then, equal siya sa Q3. Q3 ay 0.724 square root ng HF3. And so, again, to lessen the unknown, rewrite natin sa HF3 in terms of HF1. So, it is equal to 90 minus HF1. Ayan. So, here, the only unknown is HF1. So, masasolve natin si HF1. HF1 is equal to 41.347 meters. Now, you have HF1. Madali mo nang makukuha si Q1, Q2, and Q3. Okay? So, Q1 ay 4.388 cubic meter per second. Q2 naman ay 0.661. Then, Q3 is 5.048 cubic meter per second. So, those are the answer for the sample problem number 5. So, next we have sample problem number 6 naman. Two pipes, each 300 meter long, are connected in series. The flow of water through the pipes is 150 liter per second with a total frictional loss of 15 meters. If one pipe has a diameter of 30 millimeter, what is the diameter of the other pipe? So, given tayo ng friction factor na 0.02. It's for both pipes. So, we have series daw na connection ng two pipes. So, series connection. We have, na-draw natin siya from the given. So, ito yung pipe 1 natin. Then, hindi natin alam kung ano yung diameter ng pipe 2 natin kasi unknown siya. So, sulat natin yung given na mga properties. So, same pipe natin has a length na 300 meter from the problem. Then, the flow ay 150 liter per second or 0.15 no, cubic meter per second. So, yan yung nagpo-flow dito na liquid. Yan yung Q niya. So, yun din naman yung lalabas dito. So, Q, 0.15 cubic meter per second. And we have the total frictional loss. So, total frictional loss, that is HL, 15 meters. Okay. If one pipe is 300 millimeter diameter, so yung pipe 1 na rin natin yun. So, diameter 1 ay 300 millimeter. What is the diameter of this one? V2. And F natin ay 0.02. Both pipe. Okay. So, we just have to relate the Q's here and the head loss. Actually, kaya natin 'tong i-solve by Bernoulli's energy theorem or equation. But ano, lagi naman natin 'to ginagawa. So, mare-realize niyo na HL is just equal to the summation of the head loss at your pipe 1 and pipe 2. Okay. So, what is HF1 and HF2? So, it follows the equation ng major head loss natin. Since, given tayo ng friction factor, Darcy weighs back. No? 0.0826 FL Q squared over D raised to 5. Ayan. So, let's substitute the given na properties ng pipeline natin, no, to have the equation here. So, HL to total head ay 15 meters. No? It is equal to yung FH1 na 0.0826, F 0.02, L given 300 meters, Q 0.15 squared over diameter natin na 300 millimeter or 0.3 meters raised to 5. Then plus the HF2 na 0.0826, F 0.02, L ay 300, Q 0.15 squared over D natin at that point, no, D2 raised to 5. No? So, here, ang unknown lang pa na natin is the diameter doon sa other pipe natin. So, masasolve natin to agad. You can apply ship solve, but again, simplify nyo muna, no, kung kaya sa time niyo. Pero if hindi, pwede naman isolve na by ship solve kaso matagal. Okay? So, solving for the diameter, it is equal to 0.255 meters. So, in millimeter, kasi yung diameters natin, mapapansin nyo always in millimeter siya. So, solve natin. So, it is equal to 254.662 millimeter. So, these are the answer, right? For the diameter. Ayan. So, when you're analyzing series na pipelines, your Q, no, is continuous. No, kung ano yung Q mo at point 1, yun din yung Q mo at point 2. Okay? Then, the head loss mo na total is equal to the summation of the head loss per pipe. Okay? So, last problem is about this. Hindi pa pala. Series pa to, no? Yung last problem pala is about the parallel pipes. So, second to the last na problem. So, 3 pipes of different lengths are diameters connected in series as shown, discharges 160 liter per second. So, if the roughness coefficient N is 0.012, determine the head loss in each pipe and the diameter of an equivalent single pipe, no, that could replace all 3 pipes natin. So, we have pipe A, B, and C, given yung mga properties. 415 millimeter in diameter. At A, length is 1/8. Sa pinaban, diameter is 300. D is 1,500. At C, we have 250 millimeter diameter. L is 800. And given then yung coefficient ng Manning's coefficient, the 0.012. So, it applies on all of the pipeline here. So, we are asked to determine the head loss, no, in each pipe. So, calculate natin. So, the head loss in each pipe, since given tayo na Manning's coefficient, that is HF, 10.29 N squared, LQ squared, over D raised to 16 over 3. So, this is the equation for the Manning's, no, na head loss. So, using this one, masasagot natin agad itong head loss in each pipe. So, let's solve HFA. We have 10.29, Ni 0.1012 squared, Li 1,800, Q ay, ano yung Q? Yung Q natin is given 160 liters per second. So, series pipe to. We have continuous, no? 0.16 cubic meter per second. Yan yung nagpo-flow sa pipe natin. We have 0.16 raised to 2. Then, divide natin sa given na diameter, 0.45, 16 over 3. Ayan. So, let's solve for HFA. It is equal to 4.829 meters. So, that is the head loss at A. So, answer natin yan. Next, we have HFB naman. We have 10.29 and 0.012, ano, squared, 1,500, Q, same. Then, divide natin sa given diameter, which is 300 millimeter or 0.3. So, 16 over 3. So, solving HFB, that is 34.978 meters. Ayan. Then, HFC naman. So, si HFC is equal to 10.29 and 0.012 squared. L, 800. Q, same. Diameter is given, no? 0.25. Then, 16 over 3. Naka-raise. Ayan. So, solve natin agad si head loss at pipe C. Ito ay equal sa 49.328 meters. Ayan. So, we had the head loss in each pipe. No, we have follow-up question. No, diameter of an equivalent single pipe. No, diameter of an equivalent single pipe that could replace all 3 pipe. So, what does it mean? So, kapag sinabing equivalent single pipe, it must have the same flow rate. No, same Q na dadalhin and same head loss, no, HL. So, the Q in this problem is 0.16. Then, the head loss ngayon must be equal to the total of your HFA, HFB, and HFC. Kasi yan yung total head loss mo along this pipeline. So, calculate natin yung total head loss. It is your HFA plus HFB plus HFC. Yan. So, total, 4.829 plus 34.978 plus 49.328, that is equal to 89.135 meters. Yan. So, that would be the amount, no, of your head loss and the Q. Yan. So, hindi sinabi dito kung ano yung magiging length. So, the length is equal to the total length din dyan. No? So, equivalent pipe na same ng magiging length niya. Okay? So, the total length naman is equal to 1.8 plus 1.5 plus 800. No? Sulat natin. So, papalitan mo yung tatlong pipe ng iisang pipe lang. So, noting that you must have the same Q and same na head loss. So, yung length natin dito, yan pa rin. Kasi hindi naman binanggit kung pahabaan ba o iiklian. So, this would be the total length pa rin. So, 1.8 plus 1.5 plus 400, plus 800, that is 4,100 meter. Ayan. Then, for the N, hindi rin naman siya magbabago na based on the problem. So, 0.012 pa rin. So, the material of the pipe is the same. Ang mag-iiba lang is yung magiging diameter niya. Kasi i-replace na natin tong tatlong pipe na to into 1. So, what would be its diameter? So, susunod natin siya using the major head loss ni Mannings pa rin since N yung given sa atin. So, the HF is 89.135, no? You can use the stored value of that equal to 10.29, Ni 0.012, L 4,100, Q 1,6 squared, N squared, LQ squared, D ay unknown, diameter 16/3. Ayan, so you can simplify this to solve the diameter. Now, solving for the diameter, it is equal to 0.304 meters or in millimeter, no, kasi diameters are usually written in millimeters. So, ito ay 303.969 millimeter. So, this would be our answer for the diameter that is unknown. Okay? So, last na problem is a parallel naman na pipe. So, a pipe 977 meter long branches into 3 pipes at junction A. So, magba-branch siya. So, the 3 pipes has span of 146 meter, 885 meter, and 796 meter. They come together at junction B. And continue to the single pipe na 1,224 meters. Right. So, all pipes are 300 millimeter in diameter or in size except the short one. So, yung short natin, hanapin natin yung maikli. Asan ba? So, 977, 1,046, 885, 796, 1224. So, itong 796 yan yung maliit natin na sa length, no? Maliit na pipe. So, it has its own diameter na 250 millimeter. So, the pressure drop of water between the junction is 260 kilopascal. Now, between the junction, so that is your junction A and B. So, it has certain pressure drop na 360 kilopascal. So, friction factor F can be assumed 0.02 in the entire system. Calculate the rates of flow in the branching pipes. So, it is given that we have certain pressure drop na between the junctions at na 260 kilopascal. So, actually, that pressure drop, no, na 260 kilopascal will be used to determine the total head loss between this junction A and B. No? So, that is your PB minus PA na 260 kilopascal. So, if dinivide natin 'to sa unit weight of the liquid, na nagfo-flow sa pipeline natin, so we will be having the, pressure head difference 'no, at A and B. Yun yung magiging head loss mo at that junction 'no. Total head mo na yon sa junction na 'to. So, we have 26.504 meters, no? 260 kilopascal, divide natin sa unit weight of the liquid that flows here. The unit weight is 9.81 water. Ayan. So, simplify, we have 26.504 meters. Now, take note, if we're analyzing parallel na pipes, so parallel say 1, 2, and 3, so for parallel pipes, the head loss there is equal, no? Equal yan kay head loss 1, no, head loss 2, and head loss 3. That is your total na head. So, meaning, no, yung total head natin at this junction is just equal to your 26.504. So, the unknown here, no, is the rates nung branching pipes natin na branching pipe 1, 2, and 3. So, madali natin yun maso-solve if we have the equation for the major head losses since given naman na sa atin yung major head loss natin, no? So, given is the friction factor F. So, ang gagamitin natin is the Darcy waste back na 0.0826 FLQ squared over D raised to 5. Now, let's solve for Q1. Yeah, so substitute lang natin, no? HF1 is equal to 26.504 meters. So, we have 26.504 na equal to 0.0826. F is given 0.02. Length, ayun siya, 1,046. Q1 is unknown, then diameter is given 0.3, no, raised to 5. So, solving for Q1, it is 0.190 cubic meter per second. Okay? And then, H2 naman. So, si H2, o HF2 ay, again, 26.504 because this is a parallel na pipes. No, kung ano yung head loss mo dito, yun din yung head loss mo dyan, and here. So, ang magbibigay sa atin dito ng head loss, no, is from the pressure drop of the water, no, between the junctions. So, following the equation, we have 0.0826, F ay 0.02, L at pipe 2 ay 885, then we have Q2 squared over D, D ay 0.3 raised to 5. Now, solving for Q2, it is 0.21 cubic meter per seconds. Then lastly, for Q3, no, Q3, gamitin natin ulit yung equation ni Darcy Weisbach na we have 0.0826, F ay 0.02, L 796, Q3 ay unknown, so square, divide sa diameter na 0.25 raised to 5. So, Q3 is equal to 0.14 cubic meter per second. So, that is your parallel na pipe. Yan. So, if ever pinahanap yung amount of Q at your before your junction A, so at this pipe, na let's say pipe, ano kaya siya, pipe 4 na lang, tapos ito 5. So, if ever pinahanap yan, so you just have to take note that your Q4 is equal to Q5, no? And equal to the Q at the branching pipes, no? Q1 plus Q2 plus Q3. Ayan. So, we just had to add up, no? Itong mga Q to solve for the Q4 or Q5. Yung inlet or inflow natin and outflow. So, solve natin. We have 0.193 plus 0.21 plus 0.14. So, we have total flow na 0.543. Pag pinahanap, halimbawa, yung inflow and outflow. So, ayan siya. So, gawin na natin QT, no? Q total. Okay, so that's all for the subtopics of the fluid flow in pipes, the pipeline connection. If you have any question about this, you can contact me on MS Teams. Thank you guys and have a nice day.